Hi, today we have a special topics with two amazing guests. We're gonna be discussing best practices when it comes to using Power BI and Databricks SQL. My guests are Yatish and Andre.
Hello.
So can you please tell us more about you first, Yatish, and then Andre?
Sure. Hi, I'm a solution architect with Digital Native Unit in Databricks. As a part of this role, I basically help the customers in their Databricks adoption, Databricks Lakehouse platform adoption. And I'm also part of the DB SQL and Power BI SME group in Databricks, and wherein I talk about the best practices about Databricks SQL, Power BI, and how the customers can leverage the both Power BI and Databricks SQL in their environment.
And what about you, Andre?
Thanks. Hi everyone, my name is Andrei Mirsky. I'm a specialist solutions architect in Germany, based out of Munich. I work with customers across the whole EMEA region, helping with adopting Databricks SQL, helping them to get the most out of Databricks data intelligence platform. And as I have experience with Power BI, and Power BI is one of the biggest and the widest adopted BI and business analytics tool on the market. It's one of my passions, and I help customers to adopt Power BI on Databricks data intelligence platform more efficiently.
And I've been told that you have a repo where you're sharing all those best practices. Can you tell us more about this one?
For sure. So I'm really glad you asked this question, Yusuf, because we talking about the best practices, it's really important for all the organizations. And that's the reason me and Andre have actually created a Git repo, which wherein we have created all these sample templates with the three main principles. We have created with an intent that it should be open, it should be simple, and it should be multi-cloud, right? Which is what, as you would know, Databricks is like really famous for. Now, all these, and I will talk about, and I will showcase the Git repo in depth in some time. But the main intent is of this repository is to just talk about the best practices of integration between Databricks SQL and with Power BI, and just make it easy for anyone to plug and play these sample templates by using all the PBIT template files that we have attached in these repository.
That sounds good. Looking forward to have a look at the repo. And I think I have the first question for you guys. I know for sure that analysts try often to connect to different Databricks SQL environment, which requires manual tuning. So how can we streamline the process?
Sure. Streamlining the process obviously is really important, right? And to answer to your question about streamlining, let's say when the developers have to move from a dev environment to a QA environment, right? That's where the dynamic Power BI parameter connection, data source parameterization really comes in handy, right? What this means is in Power BI, you can create these variables or these parameters. And because of this, you can actually now create connections to your data sources dynamically. You don't have to do any manual work of opening those reports and changing the connection sources. So as a matter of fact, let me now, I think this is a good leeway for me to dive into and showcase to you in a step-by-step instructions in our Git repository and also show you our Git repo.
That sounds good.
All right. So as you could see here, this is the Git repository that we have. And I'm going to quickly give a quick introduction about what the Git repository basically contains. Now, this Git repository, as you could see, it talks about Power BI and Databricks SQL Quick Start Sample. All these sample templates that you see here are certain best practices or recommendations of when you're using Power BI and Databricks SQL. So you have we talk about query parallelization, we talk about different storage modes. And what you would see here is every implementation has a prerequisite, has a step-by-step instruction if you want to follow along. And at the same time, we also have Power BI template files for each and every sample templates that you see here. The intent here being you should be able to quickly run and showcase and test out all these features right out of the box. And one of these implementations that we have here, as what you see, is using parameters, which is what we were just referring to. Now, for using parameters, to be honest, it is just three-step process, right? But before I talk about those three steps, I want to make sure that I cover what are the prerequisites for it. So essentially what you need here is a Databricks account and a SQL warehouse, which is up and running. And then you also need a Power BI desktop where you would be creating your parameters. Now, to talk about step-by-step instructions, the first step of the process is creating those parameters. How you can create your parameters is in Power BI desktop, just click on the button called manage parameters, and then you can name your variable based on your requirement. Now, in this case, we are talking about integration of Power BI and Databricks SQL. For that, we essentially need two variables. One, which talks about the server hostname, and the other one which talks about your Databricks SQL HTTP path. And you can easily get all this information from your Databricks SQL warehouse, as you could see in the screenshot here. So if you go to your connection details of your SQL warehouse, you would be able to get your server hostname, and you will be able to get your HTTP path. So these two variable information is what you need to create a parameter. Once you have this from your warehouse, all you have to do is create two variables in Power BI desktop with the server hostname that you have copied and the HTTP path that you have copied in the previous step, as you could see in the second screenshot highlighted on my screen. Once you have, and to be very honest with you, that's pretty much it. Now you have these two variables which are now pointing to your warehouse, Databricks SQL warehouse. Let's say pointing to your dev environment right now. Okay. Once you have these variables created, the next step is to add these parameters and essentially update your mQuery. And it's as simple as just opening your query editor, opening your Databricks SQL data source connection, and instead of having the hardcode connection, your hardcode connection parameters defined there, all you have to do is replace it with the two variables that we created in the previous step. And that's it. Now with this, and as you would see, in the essential three steps, I'm able to now create a dynamic report and a dynamic data source connection. Now, once this is done and you publish this report, your developers will never or no longer have to open the Power BI desktop to change your connections manually, because when you publish these reports on Power BI service, these variables would automatically appear on the Power BI service. And let's say you want to change your connection from dev to QA or even to prod, all the developers have to do is just change the variable name, the connection name from your dev connection to your production connection or QA connection in the Power BI service, and they will never have to manually open or change anything on the Power BI desktop.
That's very easy, and I think you're gonna improve the productivity of many analysts rather than having each time to go and change this manually. Now everything is streamlined and simplified, and I think this is just something very easy. You have just showcased, and I think we have more to come in few minutes. So I guess we did discuss about the parameters, but what's the best approach to optimize the performance? Because I know this is a very sensitive topic. What would you recommend to use? Like the import mode, the dual mode, or which one is the best? Because I've seen some customers using only import mode, other direct mode, others like the dual. Which one is well suited for each use case?
Thank you, Seth, for the question. Indeed, Power BI is famous for delivering super performance when using import mode, when data is cached in the memory of Power BI. There is also direct query mode, which enables you to query unlimited data volumes in Databricks data intelligence platform. And we have customers who query literally terabytes of data. Power BI also offers composite models when developers can combine both import storage mode and direct query storage mode. So while some data is cached in memory, the rest is retrieved directly from Databricks Lakehouse using Databricks SQL. And oftentimes we see that our customers use these storage modes and composite models inefficiently. That's why we created this example comparing behavior and efficiency of imports, direct query, and dual modes for typical star schema data models.
Yeah,
so here we analyze the Power BI behavior when using different storage modes for typical star schema data model. So we have step-by-step instructions how to reproduce our experiment and our conclusions in the end. So here we have a sample data model using 3 flavors of the same dimension tables using direct query mode, import mode, dual mode, and we have a fact table which is configured to use direct query mode. Quite simple example, but it demonstrates how different these 3 storage modes behave. And surprisingly, when customers switch dimension tables to import mode, it leads to worse performance, actually. Not an improvement, which is fair to expect because data is imported into memory, but essentially it leads to performance decline. And that's we have step-by-step instructions. You can see the results of our tests, how the report behaves when using purely direct query mode, how it behaves when we switch dimension tables to use import mode. And you can see that here, for example, the performance of one of the visuals in the report is much worse, even comparing to direct query mode dimension tables. And eventually we test dual mode performance, which results in the best performance across the 3 experiments. And here you can also find our recommendations for dimension tables, for fact tables, and for aggregation tables, which is the next topic. So this example showcases that proper combination of storage modes will result in the best possible performance. And not always import mode wins, not always direct query mode wins. There is also a third storage mode, which is dual, which is not well known across the community, but a proper usage of these 3 modes will result in the best possible performance and the best possible user experience. And of course, as Yatish mentioned, for every best practice, for every example, including this one, we have a Power BI template, which our users can download and use in their own environments using their Databricks workspaces. We use standard samples catalog and TPCH schema, so users don't need to create any test data sets. They can reproduce end-to-end in their environments.
Yeah, I think you've simplified the way to give them more opportunity to test the template. So to summarize, like large tables, they should use the direct mode. For fact tables, they should use the dual mode. But what if I want to further optimize the performance? What should I do? Like, is there any partitioning in Power BI? I'm not that familiar with the tool.
I can take that. Sure. Yes, Power BI does have the concept of partitioning, right? And in fact, it's actually one of the most one of the most powerful techniques in Power BI, especially when you are dealing with, as you mentioned, like large data set in the import mode, right? So how it works is in Power BI, when we create these custom partitions, it creates like small manageable segments, which are called obviously partitions. And with these partitions, you can actually now process your data parallelly. Like each partition would have its own set of data, and it would process the data parallel. When you're doing a data set refresh, it is basically processing its own set of data itself, right? How it helps is, in turn, you now have these segments which are processing the data parallelly, and at the same time your query performance would also go up, and your data set refresh would also be faster, right? Actually, let me just show you a quick example of an experiment that we did and how logical partitioning really helped in that. So again, going back to our Git repo, and here we have a section called which talks about logical partitioning, what logical partitioning is and how you can do. Quickly, again, talking about the prerequisites, logical partitioning or custom partition, as we call it, especially for the import mode, there are few prerequisites and few things that you should keep in mind. It works only on Power BI Premium Workspace. In our experiment, we actually use DAX Studio, which you would see in few minutes, where I'm using to analyze the performance of and showcase the difference between logical partition when it processes, how it looks like as compared to a table which is like not partitioned. And then for creating these custom partition, you could use either SSMS, or in our case, we used Tabular editor. And then finally, you need SSMS to deploy your XMLA endpoint and process your XMLA endpoint. Now, as Andre mentioned earlier, all our templates are based on samples catalog and TPCH schema, right? And in this experiment, we have used orders table, which talks about, and then which has a fact table, which has an orders fact table. And that fact table is in import mode, right? So what I have done here is I've created a report and published this in our premium workspace. And what I'm showing here is, by default, in the screenshot, as you could see, when you publish a report for the first time, by default, Power BI just creates it's a non-partition table. So what that essentially means is all your data is just processed as a single partition in a single threaded way. So as you could see here on the screenshot here, I'm processing like 7.5 million rows, and the number of partitions is just one. So all my entire data set is getting refreshed on just that one partition. What I have done is I've created in the next step, what you see here is I've created custom partition. Like in this case, what I wanted to understand was I wanted to process the data faster, and I wanted to process it based on my different order priority. Now, there could be orders which are high priority. Then there are orders which are like medium and low priority as well, right? So what I have done, I've created here is, as you could see in the screenshot, is I've created 5 different partitions based on the order's priority, like urgent, low, medium, so on and so forth. And now, as you can clearly see, instead of having like one partition processing the entire 7.5 million rows, I'm still processing the same amount of rows, but it is multi-threaded and it is actually getting processed parallelly, and each partition is processing its own set of records. And in terms of performance and in terms of implementation, what you could see here is in the next step, I have actually tried to show that, like, if in case this is the first time when I process my default report, which is a single non-partition table, it finished in 8.5 minutes, processing the entire, refreshing the entire data set. But when I process my partition table, which is the 5 partitions that I showed you earlier, as you could see here, it actually finished in less than 4 minutes. So clearly, as you can see, I'm even processing a relatively smaller data set of just 7.5 million, I'm actually able to see like 50% improvement, all because of partitions and all because of these partitions processing the data parallelly in a multi-threaded way. So as your data set actually increases, and when you start dealing with bigger terabytes of data set on import mode, your logical partitioning becomes really powerful, because now you are able to see better data performance and your data set refreshes, and your end users would be like, would get your data quicker. So just an example, an experiment of how you can use partitions on the import mode and how it helps in the performance.
Perfect. I think we discussed three important topics: how to use the parameters to streamline the connection to different Databricks SQL environment. We talked about the best choice when it comes to choosing direct query, import mode, and the dual mode for different use cases. And we talked about how to optimize furthermore the performance on Power BI. Any additional information you want to share with us, Andre? I think you're on mute.
Sure, thank you. Thank you, Seth, for summarizing the best practices or templates which we published in the repository. I would like to wrap up our short conversation with this summary. Microsoft Power BI is the leader in the business analytics market. And at Databricks, we set the new category for data platforms, which is data intelligence platform. And we see more and more customers implementing Power BI analytics on Databricks data intelligence platform. With this repository of reusable samples, reusable best practices, we aim to help our customers to implement and optimize their Power BI solutions on Databricks SQL, both performance and cost-wise. Following best practices is the foundation for success in the long term. And our repository provides not only an overview of best practices, but also step-by-step instructions and Power BI templates, which can be easily reused in any Databricks workspace. By the way, not only Azure Databricks, but also Databricks on AWS and GCP. We are truly multi-cloud. So if you are working with Power BI on Databricks SQL, we encourage you to check our repository. We have more than we discussed today, and we are not stopping there. We will be adding more best practices, more examples in the future to help our customers to succeed.
Thank you, Andre. And just for your information, you will find a link of the GitHub repo in the description of the video, and you can leave your comments there in case you have any questions or maybe suggestions to Andre and Yatish. And again, thank you for your amazing contribution to the community and all the work you're doing to improve the performance and the satisfaction of so many customers and Databricks and Power BI users.
Thank you.
Thank you.
Thanks for having us.